Hello there, my friends. Hope you are having a really good day. So far, we have looked at three sorting algorithms, that is the insertion sort, selection sort, and the bubble sort. And in this video, we are not going to go to the fourth sorting algorithm. We are going to look at something called merging, which is very important in understanding the fourth sorting algorithm, which is the merge sort. So before we look at how merging works, I would like to tell you guys something. If you guys ever feel that my videos are too fast for you to keep up with, then I request you to change the playback speed in the settings from normal to 0.75 times. I mean, it's probably because squirrels are really fast, be it eating, talking, running, and we tend to have great reflexes too. I understand that it can be overwhelming for humans to keep up with the speed, but since YouTube has this feature, it would be good if we make the best use of it. So, as the name suggests, in merging we are going to be doing some kind of merging. And in this context, we are going to be merging lists, specifically sorted lists. Alright then, so now we shall be taking two sorted lists, A and B. So let A have the elements 2, 4, 6 and 8, and let B have the elements 1, 3, 5 and 7. So we are going to compare the elements in A and B and put them into another list C, which contains the elements of both A and B and is also sorted. So for the purpose of merging, we are going to be considering three variables I, J and K. So I is used to iterate to the list A, J is used to iterate to the list B, and K stores the index or the position where the next element is to be inserted into the list C. So initially I, J and K are initialized to 0 since we always start from the first position of each index. So merging depends on one condition, that is A of I is compared with B of J and the smaller of the two is put into C of K. So this is what we are going to be doing again and again in the merging algorithm. So initially I is 0, so A of I is 2 and B of J is 1. We know that 1 is less than 2. So the element that needs to be inserted at C of K, which is C of 0, that is at this position, will be 1. So now 1 is already inserted into the list C. So we need to move on from 1. For that, we will be incrementing J by 1. So we are not going to be comparing 1 again with any other element of A. So J is incremented by 1. Also, we need to increment K by 1 since the 0th position is already filled by some element. So K is also going to be 1. So now as J has become 1, B of J shall be 3. So 2 and 3 are compared and it's found that 2 is less than 3. So 2 needs to be put into C of K, which is C of 1. That is this position, second position, and 2 comes here. Now the first two positions in C are filled, which means we need to move on from 1 to 2. K should store the value 2, which is the next position of insertion. And also 2 is already put into the array C. So we need to move on from 2 to 4. And for that, we should increment I also by 1. So I becomes 1. So now A of I is A of 1, which is 4, and B of J is 3. 4 and 3 are compared and it is found that 3 is less than 4. So 3 goes into C of K, which is C of 2. So this process is continued till all elements are put into the list C. So next 5 and 4 will be compared and 4 is put into the list. 6 and 5 are compared and 5 is put into the list. And 7 and 6 are compared and 6 is put into the list C. Then 8 and 7 are compared and 7 is put into the list C. So now we have come to the end of list B and there is no element in list B which needs to be compared with a list with an element in list A. So one element, that is 8, is left out in the list A. So what do we do about it? It's really simple. We are not going to compare 8 with any element and we are just going to put it into the list C. So as you can see, we have the merged list C, which has all the elements of A and B and is also sorted. Okay, I guess it would help you guys a lot if I just write the pseudocode over here. So let's get started with the pseudocode. First, we'll be writing a function called merge. This is the definition of the function. So what we are going to be passing through the function is array A, the array B, and let m be the length of the array A. We're going to pass that to, and n be the length of array B. We'll pass that through the function merge. So these four parameters are passed through the function merge. So inside merge, firstly, as we saw earlier, I is initialized to 0, j is initialized to 0, and k is initialized to 0. So now, first we need to check if we have reached the end of the array or not, because if we reach the end of the array, come out of the loop. So obviously we need a loop over here. So while I is less than m and j is less than n. So if I reaches m, then it has gone out of the range of the list. So this is the boundary condition. So now comes the main statement of the merge function. So we're going to check if a of I less than b of j. We might as well include an equal to here, because if the elements which are to be compared are equal, we can add them in any order. So adding an equal to here does no harm. So if this is true, we are going to put that element into the kth position in the array C. C of k is equal to a of I. And let's not forget that we need to also move on from I, and we also need to increment k, because we need to go to the next position in the array C. So that will be for this condition. So next I'll be going here, since I don't have a lot of place. Else in a sense, if b of j is less than a of I, what we need to do is C of k is equal to b of j, and we'll be obviously incrementing j and k too. So yeah, that completes it. So we finish the while loop over here. So next we have got to account for the left out elements in each list or array. Please note that I'll be using the words list and array interchangeably, because let us for now at least assume that both of them work the same. Okay, so now we have got to account for the leftover elements in array A or array B. So for that we should include two for loops, one for array A and the other for array B. For P in range I to M. So for all the elements in the pth index to the mth index, we are just going to put all those elements in the array C, and since they are already sorted, there is no problem for us. So C of k is equal to A of P, and don't forget that you have to also increment the value of k. So we have to also include the for loop for the array B, and I'll be writing it over here because I don't have a lot of place. So for q in range j comma n, C of k equals b of q. So the qth element in B will be put into the next position in C, and again we are going to increment k by 1 and close the for loop, and we also have to end the merge function, so this bracket is for that. So this is how the pseudocode looks. The pseudocode of merge function looks, and if you are finding this to be a bit overwhelming, I can understand, and I can assure you that you will definitely understand it better when we implement this merge function in Python in the next video. So that's it for this video, guys. Stay tuned for the next video. Bye for now.